Namaskar. Welcome in this lecture series on software engineering fundamentals. Uh, this is Dr. Bright Keswani, professor in computer science and engineering in Suresh Gyan Vihar University, Jaipur. In today's lecture, we will discuss about software design principles. It is the part of software design fundamentals. So let us discuss about some major basic and constructive software design principles. First of all, we will discuss about the learning objectives and learning outcomes of this lecture. Through this lecture, you will learn about the software design principles in details. What is expected learning outcomes? After the completion of this lecture, you will be able to understand about various software design principles and how to implement the standard design principle when designing a quality software system. So you will understand about the software design principles because there are a lot of principles, software design principles, and what what design practices you have to adopt for a complex project is depends on the better understanding on software design principles. So these are some points we will discuss in this lecture: basic design principles, constructive design principles, and conflict between software design principles. So let us start this lecture with the first agenda, which is basic design principles. So as you know that software design activity is a very long activity and very crucial also, because there are a lot of concepts, designing concepts are there, and you have to if uh, you are claiming that you are a good designer, so you must know about all the design principles, all the concepts in best concepts of software design. Okay, so software design shares many design characteristics with other design disciplines because of the universal design goal of creating high quality, long lived products. For example, all designs should meet clients' needs for functionality, for reliability, for efficiency, and for consistency. So, if you claim that your software is a quality software, your software design should be also a quality design. Okay, so to to make to develop a good design, you should know the software design principles. That is the fundamental need. So there are so many characteristics of designs. There are mainly software design principles fall in two categories. First category is basic design principles, and second is constructive design principles. So in this lecture, we will discuss about both type of classes in very detail. Basic design principles consisting of principles of adequacy, principles of economy, and principles of changeability. Whereas constructive design principles based on modularity, implementability, and implementability principles and aesthetic principles. Let us discuss all types of principles one by one. First of all, we are discussing about the basic design principles. So when we talk, the primary goal of software design, as you know, is the specification of the software system meeting a software system meeting client's need and satisfying design constraints, design related limitations. And such a system must have certain characteristics at a delivery and must be maintainable over time. Specifically, at delivery, the system must satisfy its requirements and conform to its design constraints. To be deliverable, a system must be designed so that it can be built for an acceptable amount of time and money. A system maintainable over time must be changeable. Remember this thing. And these considerations give rise to the three basic design principles, that is, principle of adequacy, principle of economy, and principle of changeability. Okay, let us discuss about the principle of adequacy. The bottom line for any design is that it must specify a system that works, that is, one that satisfy all requirements subject to design limitations. So first aim of designing to provide a workable system, workable software. The second principle of design is to provide the quality workable software. Okay. If no design can do this, then the requirements or the constraints must be changed in consultation with the client. So what is needed? Consultation with client is needed. The client must be the arbiter of the design problem, not the designer. He will suggest you what type of changes required, but don't expect from him to design your software. Okay, the designing of software is the work of software designer, not the client. So don't expect design from the client. Adequacy is clearly the most basic demand that any design must satisfy. Thus, the first principle is evaluating any design is the principle of adequacy. So you can say that design must specify systems that satisfy product requirements in record in as per the design constraints. So what is as a principle of adequacy? Adequacy is clearly the most basic demand that any design must satisfy, and design must specify systems that satisfy product requirements as per the design limitations, as per the design constraints. Okay, if a design does not meet its requirements and conform to its design constraints, then any other uh, virtue it may possess are without value. So the effectiveness of design is important. It should be when you are going to make a design, you should confirm that you should confirm first that it will fulfill all the requirements of your client. Okay. Second is principle of economy. Software development is expensive and time consuming and is usually done on a budget and according to the schedule. So design, when we are planning for the software, planning to develop a system, we have already decided that what will be the time limit for development on new product. So it should be because software development is an expensive and time consuming activity. So you should follow the design, the economic or budget or time related constraints. Okay. Designs may be more or less easy to realize. To be acceptable, a design must specify a system that can be built, tested, and deployed on time and within the budget. So what is important? Delivery of the design is very important. In time delivery is very important. Tested testing of the design before the delivery is very important, and within the budget is very much important. So you should make a design which is economic, which is timely tested, and which is timely deployed. Okay. So the principle of economy, you can say, is design must specify systems that can be constructed on time and within the budget. The principle of adequacy and economy may be in conflict. What is that conflict? It may turn out that the designer is unable to specify a system satisfying requirements and conforming to design constraint that can be built on time and within the budget. The designer must then work with the client to study trade-offs between requirements, design constraints, time, and money. Okay, so economic designs should be within the budget. Design should be delivered in time. Okay. The next and last basic design principle is principle of changeability. Design that make a product easy to change will have a tremendous influence of cumulative life cycle cost. About 70% of the cost of software product over its lifetime is occurred in maintenance. So you are doing your maximum efforts in the maintenance of the software. Okay. As per an estimation, 70% of the cost is involved in the maintenance process. So the principle of changeability states that designs that specify system that are easy to change are better. Okay, so make the design which is, as you know, that client is always changing their needs. The client is changing their needs frequently. So what to do? How to resolve this kind of problem? The principle of changeability suggests that make make the software designs that specify systems that are easy to change. Okay, make your systems easy to change. There is no absolute standard for changeability as there is for adequacy and economy. The goal is simply to make systems as easy to change as possible. Okay, so make your designs simple, as easy to change as possible. The second agenda is about constructive design principles. What are the constructive design principles? Constructive design principles provide criteria for judging particular aspects of designs or for choosing among design alternatives that result in overall designs that meet the basic principles. Constructive design provides the criteria for judging particular aspects of designs. Okay, so you can divide these principles into several categories, like modularity principles are there, implementability principles are there, and aesthetic principles are there. Let us discuss these principles one by one. First of all, modularity principle. What modularity principle suggests? We have learned over the years that high quality software systems are invariably constructed from self-contained, understable parts with well-defined interfaces called modules. Okay, and which is the major aim of software engineering, to make the software reliable, make the software reusable. So the concept of module is to make the software reusable. Several important constructive design principles are about how to design good modules, provides you the concept of modularity. So module related principles provides you the suggestions that how to design good modules. Okay. Implementability principles. A design may be more or less easy to build. Ease of construction affects both adequacy and economy. So, easy to implementable design should be more easy to build, and it should be easy to maintainable. Okay, yeah, implementable. Next is aesthetic principles. Although not universally acknowledged as an important software design principle, beauty may contribute to design quality. So, let us discuss the first modularity related principle. These are the there are several principles. Main are categorized into five, divided into five categories. First is principle of small modules. Second is principle of information hiding. Third is principle of least privilege. And fourth is principle of coupling. And last is principle of cohesion. So when you talk about the modularity principles, there are this type of principles are divided into various categories. First of all, we will discuss about the principle of small modules. The simplest rule of thumb in forming module is to keep them small. So because large modules are hard to understand, hard to explain, hard to document it, hard to write, hard to test, hard to debug, hard to change, and hard to reuse. So the uh, simplest rule of thumb is what? To keep the module small. Okay, so modules should not be too big. This is the ultimate goal of this principle. The ultimate goal is to keep a module small enough to be a conceptually simple, comprehensible unit. The bottom line is that designers must rely on their experiences, engineering judgment, and recommendations of peers in deciding whether a component is a conceptually simple or comprehensible unit. So, what principle of small module suggests? Principle of small module suggests that module should not be too big. Next is principle of information hiding. Information hiding is shielding the internal details of a module's processing from other modules. Okay, so what principle of information hiding suggests? Principle of information hiding suggests that the module should hide private informations. Okay, information hiding is good for both the modules, that hides its internals and for the rest of the program. So information hiding modularity principle is very important. How now the question is how it is good for module. It is good for the module because modification of module internals from outside the module is prohibited, and this prospects the module from damage by its external code, makes module repair and enhancement simpler, and makes module reuse easier. Okay, so information hiding provides a good module to you when you adopt the information hiding concept. The next thing is principle of least privilege means what? Module should not have access to unneeded resources. Information hiding is about a module restricting access to the details of its internal processing. A complementary principle is that a module should not have access to resources that is that it does not need to accomplish its goals. So this is the principle of least privilege. Uh, it suggests that module should not have access to unneeded resources. In the worst case, a module with access to unneeded resources can be the source of serious problem such as security breaches. Okay, so there are various examples of violations of principle of least privilege, like modules that import packages or modules they don't need, modules with unneeded access to file system or databases or other computers, and source code that includes unneeded header files. Okay, so these are the examples of violation of principles of least privilege. The principle of coupling is a very important thing. Coupling is a measure of the degree of connection between pairs of modules. So you can say in easier words that the connectivity between two modules or interrelationship between two modules is called coupling. So coupling is a measure of the degree of connection between pair of modules. The strength of module coupling depends on module communication, because strong communication between modules means strong coupling, high coupling. Okay, pair of modules that communicate extensively or communicate in less desirable way are strongly coupled, or tightly coupled pairs that communicate only a little and in desirable way are weakly coupled, and pairs that do not communicate at all are not coupled or are decoupled. Okay, so we can say that what principle of coupling suggests? Module coupling should be minimized. This is the principle of coupling. What is the principle of coupling? Module coupling should be minimized, because coupling is basically the interrelationship between two modules. So when you reduce the uh, relationship, or when you minimize the relationship between two modules, when you minimize the dependency of, between two modules, you will make your software more quality software. Okay, more strong software, more acceptable software, more simple software. Okay, so reduce the complexity. What is the uh, key aspect? To reduce the complexity from the system. And how to reduce the complexity from the system? Design principle of coupling suggests you to minimize the level of coupling when you are going to design some modules. Okay, so strong couple modules are hard to change independently, because much considerations must be given to the data going out to and coming in from other modules. Strongly coupled modules are also hard to understand. It is hard to explain and hard to document, because they cannot really be considered independently of the modules to which they are coupled. Finally, strongly coupled modules are harder to test, harder to debug, and harder to maintain, because they cannot be treated in isolation. Corrections or enhancement in uh, such a way is a bigger and more difficult job. So modularity in enhanced when coupling is minimized. So the principle suggests that module coupling should be minimized. Okay. Then the cohesion, principle of cohesion. Let us discuss about the principle of cohesion. What is cohesion? Cohesion means the connectivity, the communication of in components, communication between the components of the same module. Okay, so cohesion is the degree to which a module's parts are related to one another. Cohesive modules hold data on a single topic or related topic, perform a single job, carry out a responsibility, and have a clear role or purpose. Cohesive modules have parts that belong together. A module, all of whose parts are strongly related, is said to be cohesive or to have high cohesion. A module without a strongly related part is non-cohesive or has low cohesion. So what is the principle of cohesion? Module cohesion should be maximized. And what is the principle of coupling? Module coupling should be minimized. So these are the principles of this is the principle of cohesion and principle of coupling. So when you make your software easy to code or easy to test or easy to debug or easy to maintain, what to do? What to do to make a software easy to maintain? Module cohesion should be maximized is the uh, uh, only way to make your software simpler. Okay. Then implementability related principles. Let us discuss about the implementability related principles. Software development is expensive and usually done on a budget and a schedule. Design Designs that are easier to implement will usually be cheaper and faster to implement as well. Implementability principle helps achieve overall design economy by providing criteria for judging whether a design can be built as easy and cheaply and quickly as possible. So there are two implementability related principles. First is principle of simplicity and second is principle of designing with reuse. What principle of simplicity suggests? Simpler design can usually be created, documented, coded, tested, and debugged faster, as I earlier said, and are generally less error prone to start with. Hence, it is clear that simplicity is a major contributor to design implementability, leading to the principle of simplicity. Simpler design are better. This is the principle of simplicity. Okay, you you should note down this concept that simpler design are better, which is the principle of simplicity. People drawn to software development tend to enjoy the challenges of solving complex problems, and unfortunately, with complexity leads some designers to make their creations more complex than necessary. So the principle of simplicity provides you, suggests you that to make your uh, system, your software in a simple manner. Okay, let us discuss about the principle of designing with reuse. With reuse, reuse means reusability. Your software should be reusable, which is the uh, uh, main concept of software engineering. So, what is the main objective of what this principle suggests? What is the main objective of software engineering? Principle of designing with reuse. Systems should be designed to reuse existing assets as much as possible. So what is the concept of reusability? System should be designed to reuse existing assets as much as possible. This is the concept of principle of designing with reuse. Okay, software reuse is the use of existing knowledge to build new software products, and items reused during software development may range from project project plans through product requirements, design components, code components, test plans, and test cases. Anything that can be reused is termed as asset. So, what is the aim of the principle of designing with reuse? The principle of designing with reuse suggests to use the existing assets. Okay, reuse has great productivity and quality benefits, and software designs offers many opportunities for software reuse. There are mainly two aspects of reuse. Okay, first is designer can use existing assets. That is called design with reuse. Designers can use existing assets. The second one is designers can create work products intended for reuse. That is called design for reuse. Okay. So design for reuse and design with reuse are the two aspects of reusability. The first of these aspects of reuse has a great effect on design implementability, leading to the principle of designing with reuse. Means systems should be designed to reuse existing assets as much as possible. Okay, and through this principle, we can get the quality, we can increase the productivity, and make the software quality. The last one is aesthetic principle of beauty. In many other design principles, beauty is the main goal of design. So the aesthetic principles are important in software design. Any design that satisfies requirements and conforms to design limitations gets done with need to be done. So for a given problem, any appropriate design is as powerful as many as any other, but a simpler design will be better. This is why power must be combined with simplicity. So what principle of beauty suggests? The most beautiful designs are those in which extremely simple mechanisms are able to accomplish a great deal. So, what is the principle of beauty? Beautifully, beautiful means simple and powerful designs are better. This is the principle of beauty. Okay, to make designs simple and powerful is the beauty of your design. So, make beautiful designs, which is you can say is the quality design. Okay, so this is the some designs are simple and quite powerful, yet seems awkward or crude. Beauty has been an object of philosophical investigation, and the nature of beauty is still an open question. So this is all about the designing principles. Some conflicts between software design principles. It is almost impossible to simultaneously satisfy every design principle in any design. It is almost impossible that there are so many design principles and you can achieve, you can fulfill, you can satisfy all designing principles in a particular design. It is nearly impossible. So no matter what priority ordering is given to design principle, however, engineering judgment and accepted good practices are the ultimate basis for resolving conflicts between design principles in particular cases. So if you have many projects and you have some you already known all designing principles are already known to you, then take one, two, or three designing principles and make them apply on your software design. Okay, and definitely you will get appropriate results from them. So there are, although conflicts are there, but you can use not all design principles. You are not able to use all design principles at once on a single project, but as much as you can adopt all, you can try to adopt all the principles at once. Okay, so this is all from my side. Now this is the time of assessment through multiple MCQs, multiple choice questions. The first question is, independent modules are easier to maintain and test because of dash. These are the options. Code modification is limited, error propagation is reduced, reusable modules are possible, and all of the above. The answer is all of the above. Software is divided into separately named and addressable components, and it is called as dash. Software, cohesion, module, or none of the above. What is this? What is the answer? Answer is C, module. Module is separately named, software is divided into modules, and they are separately named and addressed components. Okay. In the third question, dash is an indication of the relative interdependence among modules. Cohesion, coupling, modularity, cohesion and coupling. What is the answer? Answer is B, coupling. Coupling is an indication of the related interdependency among modules. Okay. The fourth question, why does software engineering design shares many design principles? The common design goal of creating high quality design, the first option. Second option is for expansion of product lifetime. The third option is all of the mentioned. Fourth is none of the mentioned. The answer is C, all of the mentioned, means common design goal of creating high quality design and for expansion of product lifetime. These are the designing principles. The next question, why are the design principles considered unique? Because they are characteristics of well-constructed programs, they are robust, all of the mentioned, or none of the above. The A is the right answer. They are characterized of well-constructed programs. The sixth question, which among these is the primary goal for software engineering design? A, to specify the structure of program satisfying software product specification. Second is to specify the behavior of programs satisfying software product specification. C is all of them mentioned and D is none of the mentioned. The answer is C. C means all of the mentioned, means to specify the structure of program satisfying software product specification, and to specify the behavior of program satisfying software product specification are the primary goal for software engineering design. The seventh question, what is true about good program? A, good program must have certain characteristics at delivery and must be maintainable during time. The B option, a good program at delivery must satisfy its requirements. C, a good program must conform to its design constraints. And D, all of the mentioned. All of the mentioned is the right answer. What is the principle of feasibility? A design is acceptable only when it is realized. The second option is designs that make easier to change are better. The C option is designs that can be built for less money in less time with less risk are better. And the last one is designs that can meet more stakeholders' needs and desired subject to constraints are better. A design is acceptable only when it is realized is the correct answer of this question. Okay, this is the principle of feasibility. Which principle states the following? Designs that make easier to change are better. The principle of feasibility, principle of economy, principle of changeability, and principle of adequacy. The principle of changeability suggests that designs that make easier to change are better. What is the answer of 10th question? The question is, what is the principle of economy? A design is acceptable only when it is realized. Designs that make easier to change are better. Designs that can be built are for less money, is less time, in less time with less risk are better. And designs that can meet more stakeholders' need and desires subject to constraints are better. So the answer of this question is C. Okay, so these are some self-assessment questions. If you have still you have any doubt, then any query, then consult with these books. These are the uh, prominent uh, reference books in this for this lecture. I hope this lecture provided you clear-cut understanding about the software design principles. Uh, have a good day. Thank you.